Thanks for joining me today. How was your conference so far?
Great. Good.
Awesome. My name is Marius Bogoevici. I work for Red Hat. I lead the data commons work on the data mesh in the OS Climate project. And I also work as part of the field CTO organization. Our role is to focus on engaging with clients as part of the engineering organization and with the community and help drive innovation. So a lot of the stuff that I'm talking about today comes from my work in FINOS and comes from my work with customers, particularly in financial services. And the reason why I'm so excited about this is because, let me ask you this. How many of you think that you have data problems at work? Data accessibility, data quality, all kinds of things. I asked the question differently if you were in the talk that we did with Richard and Steven, and I asked who doesn't think that they don't have a problem. Nobody raised a hand, but I don't know if they were paying attention or not. But it's true. There are many, many problems, and we kind of built data commons in OS Climate to try to solve some of the challenges that OS Climate participants had in accessing and using data. And the thing is, data is available. Like for many of these projects, there is public utility data. There is a variety of sources and organizations that publish data in different places, but they come in different formats. They come in different shapes. So you kind of need a platform to bring it all together. And there are some basic tenets to this. A belief in open source as a driver for innovation. The idea that we can help kind of like bring the different actors and reduce the friction between producers and consumers and increase the transparency of the way in which data is produced and consumed. And to have to make it easy for different participants to use their analytics tools. When you peel it off, and this is the part that I'm kind of like why this talk is not just about OS Climate Data Commons, is that if you peel off the climate aspect, if you peel off the idea that you're producing, that you're trying to derive insights from climate data, pretty much every financial institution has exact similar problems and has to solve their problems with a platform like this. Now, I'm not to understand our foundation, the foundation of what we're talking about, the foundation principle is the data mesh in here. And you can find more information. There's a great set of resources and books that talk about all the different principles that make up that help you build a data mesh. The important part is that the data mesh is a socio-technical construct, which means that you have to have the right tools and technologies, but also combine them with the right practices. It has 4 basic tenets. One, focused around the idea that data should be treated as a product. We'll talk about that a little bit later. Someone should own that process and be accountable. It has the idea that if I want to use tools and technologies, I should have them on a self-serve platform rather than having to build them and install them myself. And the idea of federated governance, which means that you can shift left some of the responsibilities of governance. Like, for example, and we're talking lineage, discovery, or data access. You can set up some policies at a global level and let each producer kind of define their own rules. And the idea is that by combining these things, again, there's a lot of information on these slides, and there's a lot of way to go in details. There are a number of approaches to get access to analytical data. You have data warehouses, which are where data is kind of curated. It comes directly from the systems, and that is that requires a lot of work to extract data, move it, and do other work with it. You have the data lake concept, which kind of pulls everything together and makes everything accessible. But it has its own challenges in terms of how data is structured, how it's accessible, how consistent is kind of you work with that particular data. And there is one thing that kind of differentiates things when you kind of look at a network of globally distributed producers and consumers of data, which is they live in different sources and different places. You don't want to move that. You want to federate that data. And for that, data mesh provides a better model. Let's take a step back and talk a little bit about the personas that are involved in this, in this process. And there are multiple actors in here, but I'm going to focus today on 3 of them. Data scientists, data engineers, and application developers. Because really, these are the main beneficiaries of the platform. Data scientists want to understand data, want to work with it. Application developers want to kind of get the insights that data scientists have derived and build better, more intelligent applications with it. And data engineers want to build data pipelines that help get the data in the shape and format that data scientists and application developers require. And one of the problems that none of these 3 personas have is that there is not enough data to go around. There's plenty of data to go around. Public data, private data, data locked in enterprise silos. It kind of lives everywhere. The problem, as we discovered, for example, in the process of building data commons, is that this data is fragmented. It follows inconsistent standards, both in terms of format or even representation. Different measurement units, all kinds of inconsistencies like that. Sometimes, the data quality is often unreliable. You have the complexity of a regulatory environment that's basically, on the one hand, kind of regulating what data should be produced by companies, for reporting. On the other hand, you have all kinds of restrictions on the privacy of the data that you access. So I'm not just saying that to see what I'm kind of to substantiate that with some numbers. Here is basically a study done by Deloitte last year on the banking and capital markets industry. And you see the numbers here. When I asked at first, who thinks that they have proper access to data and so on, this is what basically pretty much everyone is saying. Either it's unavailable or takes too long, or even when data is available, it's not in a way that it's either of poor quality or there's friction in how I can use it in terms of accessibility. So that kind of brings you to a different way at thinking about data. And this is where adopting a data product mindset is so important. Making the leap from data sets to data products kind of gives you a more consistent, more accessible, and more structured way to think about how you publish and consume the data. Data products are really kind of collections of data sets that are packaged together with documentation, with metadata. They're designed towards a specific business value. So there's a qualitative difference. We'll talk a bit later, about one of these kind of data sets. There's a qualitative difference if I say I'm going to give you data about mortgages in the United States, or I'm going to give you this Excel file that contains data about mortgages in the United States. When you when you start thinking about the purpose of that data product, then you start have to design it in a certain way. You take accountability for it. And that is basically an inherent characteristic of data products. The experience is different. Data products are designed to be discoverable, addressable, and so on. And we'll talk a bit later about how we solve this particular problem. You see here an example of, again, another survey, to substantiate this comment about data products. It's not that this is not recognized in the industry. You see, 92% of executives surveyed by KPMG, and this is from this year, say, data products are critical. We plan to increase our investments. We don't get the results that we expect. So in putting things together for our solution, we also think about how to build data products more efficiently. And this is where we bring the concept of data as code. And data as code means that we take the same approach with data as if it was the source code for an application. If an application is a product, then the data that then the source code of the data product should also be available and versioned. And that doesn't just mean that I'm going to dump a CSV file into GitHub and get done with it, because that's easy. It means that I'm going to provide references to the raw data, the original data sets where this data product came from. I'm going to provide the code that I'm going to put the transformations. I'm going to create a governance model around this, and I'm going to put the same collaborative review that I have, for example, for pull requests around versioning this data. You'll see an example of a data product and the code in a moment, how we build it. The advantage of this is that once I have this, I can go and rebuild that data product as many times as I want in whatever environment I want. This is very important, for example, if you want to process that data into a local environment, where you don't necessarily want to share. You can share, for example, the code for normalization and everything, but you don't necessarily share the raw data because that is private. The other part here is that when we say we version everything, we package things in such a way that we can apply this. We can take this artifact that we have, and we have a standard set of tools that operate on this artifact, for creating the new data, for creating a deployed version of that data set, and essentially kind of building it. We're also kind of putting in, we're not just looking at doing the transformations, but we're looking at other components in the platform that help with governance. For example, making that discoverable, recording automatically the lineage, and enabling. When we call self-service consumption, I really mean I don't want to go and set up the different tools. I want to have the platform there. I want to take my data product definition to the platform and let the tools do their job. Now, these are the components. These are the components that we use in our platform. And we settled around them because they had different qualities. We have Airflow, for example, for workflow management. We have, metadata management components, right? Open metadata, Marquez. We're working at adding Unity Catalog as an option. We have, you have a data ingestion layer. So, all these all these transformations, for example, that we orchestrate through Airflow, we can put them declaratively in something like dbt, or we can use, Spark, Spark libraries to do this. And then we provide a storage layer for this entire thing to be able to run, execute, and basically provide a live view of the data as it gets deployed. So if I'm looking at, this is basically the life cycle of a data product through this platform, right? Codifying the data pipelines, which in our case are Apache Airflow DAGs, DBT models, usually the DAGs orchestrate the DBT models, or transformations which can be written in raw Python using different libraries. So you have them. We provide, for example, we use a local version of the tools so that you can iterate and have an inner loop for development locally. And then when you're ready, we use CI/CD to basically take this data product that's been committed in Git and use Argo to deploy it on the on the running platform. So when you kind of like take this data product, the Airflow piece executes the DAGs, executes the transformations, moves the data through the object storage layer, ingests it either directly or running federated queries for inserting it, creates the tables needed. And then in parallel, it also registers the metadata, automatically the metadata and the lineage for this data set. And so what happens is that at the other end, I have, like once this data product, like I can simply take this, I can simply export this data out and publish it in whatever format I want. But once it lives on the platform, I can execute, like I can either have a data scientist discover it, and do, either, use either Jupyter notebooks or Superset, for example, for deriving insights. Or, it can do, I can discover data products by lineage, tell me, for example, what data products have been created from, are a derivative of the power consumption data set or the mortgage data set and so on. And I can also view if I need, for example, to change the current version of the data that I'm using because something changed in the backend, so there is a new version existing right now. So I can see, for example, how old was the original data set. And as an application developer, I can take this data and, because tools like Trino, for example, that provide both federated query and SQL capabilities, I can go and query directly in applications and I can run them directly. So let me show you how this works. I have an example running on my machine. It's a very simple example. It's a pipeline built using the Fannie Mae single-family mortgage data set. And we used it in the structured finance hackathon that FINOS ran in like 2 weeks ago. And do you see my screen? Is it too big? Should I make it a bit bigger? Should I zoom in a little bit? So this is my DAG right here. This is my definition of the data set, codified, like my data like basically my data product consists of, a file. In this case, we're storing the file because it's really small, but we could have downloaded it, as part of the build process. And the rules for transforming it into a new deployed data set. What I want to do is to apply some normalization and some simple transformation rules and upload it as a table, that I can query later using a Jupyter notebook. So I think I need to relog. So this is the Airflow instance. In this particular case, I'm running this on my machine because it's easier, and I want to show also the local development piece. So I'm going to start this process. I can see the kind of the pipeline running. The pipeline is made up of 2 tasks. Very simple: transform and upload, and insert to Iceberg. And once it completes executing, I can go, for example, to Jupyter and start querying it. So this is a simple set of queries, just running some selects, and then seeing the data being accessed in here. If I look at the min.io console, for example, min.io is my object storage. I'm using min.io as the object storage capability underneath the kind of like for the platform. I can see the different data structures in place. But more interesting, I can go to Marquez, which is my lineage tool, and I can see the different executions and the lineage of the various data sets. So, I can take a look and say, look, this particular transformed version, for example, that's been run, has been run this morning, by by this particular job and so on. And if I refresh, for example, I can see the updated versions of the different data sets. This kind of looking at the latest version in there. But what you see here is that I'm taking a simple set of raw data, a simple set of transformations. I'm having a predefined platform, and I'm just executing these transformations across the platform. And what I'm getting is data that I can access, data that I can locate, and data that I can understand its provenance. I can see that actually this simple family loans table, which is a table that exists in a specific catalog, originates through 2 different jobs in this initial data set. This is a more complex example of the, this was kind of a easy, quick overview. This is a more complex example that we've built for a transformation in, as part of OS Climate's, it's really a climate data transformation in here that's trying to create, basically it's trying to correlate the sovereign, the carbon footprint of each country with the value of its sovereign bonds. Basically, it's telling you that if you're buying sovereign bonds from this country, this is the kind of this is ultimately the climate impact that you're going to have. There's a methodology behind it, and What I'm trying to show you is less about that part and more about the fact that I'm having 3 original data sets that are coming from 2 different sources, from the one from the World Bank, from the OECD, one coming from the UNFCCC, from the United Nations. I have to aggregate, transform them, and build them so that they can be visualized. And that's how a graph would look like. And if I'm looking at the code for that, it looks like this. So you see multiple DAGs with DBT transformations, that have, where I declaratively describe what's happening to the data as SQL queries. So this is a good example. And this is a good example, for example, of using Python. This is a SQL query doing a transformation of a table, and all I have to do is kind of put it in here, and the Airflow DAG will automatically execute it. Now, what we're trying to do next here is we're trying to make things more container friendly. I talked a little bit about how we want to make it easy for people to develop locally and on the platform. All this stuff in here, as you can see, can run, for example, locally with something like Docker Compose, but it's really intended to be run on a platform like Kubernetes or OpenShift, anywhere in the cloud. You have the platform up there, and you upload the code there for you. But we put a lot of effort of also kind of allowing local development and making things simpler. We're working at improving our data product template. And we're looking at integrating some features like, for example, you've seen right now, for example, we treat data versioning in a more explicit way. Like I have to change references and do this, all this work. We want to integrate DVC so that we have local data versioned that you can do the process. And right now, for example, all the data that's being deployed, it's accessible through Trino. We want to offer an API-based data access for it. And we want to make it support for other work streams. I'm gonna end here because we're at the end, and if you have any questions, I can take one. But I just want to my call to action is help us build this better. Help help us build data products that test the platform. Help us build help us build and integrate new components in the platform. It's an open source. It's an open source effort. So, the different participants are contributing to it. So we would like you to be a participant. And that's all I had. Let me know if you have any questions. Thank you.